Hello and welcome to episode 2. We didn't have a title last week, so now it's going to be titled Developing with Observable and WEBCode. I'm joined again by Gabriel Koch of AgriPatterns fame. So last week we were developing our smart farm application using observable technology, and last week we achieved getting data into Firebase, but it was synthetic data, and this week we want to get real data from a sensor system deployed in the field all the way over the Atlantic and into our systems here. I'm in Berlin. Gabriel's in, where are you based?
I'm in Durham in the Research Triangle Park of North Carolina.
North Carolina. And where's the sensors?
Sensors are in near Bogota. It's in Colombia.
Wow, so this is a super global live stream today. I'm really excited because this is the episode where I'm going to bring out WEBCode, which is the product I developed. So I love observable. Last week was just pure observable on Firebase. This live stream, I'm going to bring out WEBCode, my baby, and show you how much easier it makes integrating third-party systems like Blues wireless sensor, webhooks, that kind of thing. It's going to be really slick. So we'll get to that later. Gabriel will tell us more about the kind of application they need in the field. But first, I'm going to show. We're going to start with the tarot reading. That's going to be our new thing now. So I've got this application. This is also coded up on WEBCode. So all 100% on the observable platform. And this is a demo that shows you that you can build production things that don't look anything like observable. If you really wish to, you can completely white label an app, and if you look at the domain, this is called the Tarot Online. It's just a bit of fun, but it integrates. I'll show you what it does. So, who asked the cards? Who is this tarot reading for? So this is for Tom and Gabriel. What is the question? Will our live stream today be good? We are into, so it helps if you give it a bit of material for the tarot reader to jam off. We are integrating Blues wireless sensors with Firebase on observable HQ notebooks. So what? I can't spell. Observable HQ notebooks. Right. Okay, and then we have to pick 3 cards. This is a past, present, future 3-card tarot spread. In the past card is the King of Swords. Swords often means conflict or fighting. In the present, we've got the Fool card, Major Arcana. That's pretty interesting. And for the future, we've got the Chariot card, which is pretty much the best card there is, I think. So the way this application works is we generate a random set of cards, and then we ask OpenAI to fill in the blanks based on who the cards are for and that little prompt we gave it. And the reading it's given us is, the King of Swords in the past position suggests that the live stream will be a success. The present position of the Fool suggests that there may be some last-minute surprises. It's live, but these will not affect the outcome. The future position of the Chariot suggests that the live stream will be successful and go according to plan. So that's just awesome. And if you want to share that, you can take a link. So I've got this notebook that we're going to be developing. I've cloned it from last week. So this is our ongoing notebook. So we need our tarots for the episode. Very important. I'll expand that later. Is that card there? But maybe I should pass over to. There's going to be a lot of like technological rubbish where I haven't really set OBS up properly, but we're getting there. Let me pass it over to Gabriel to talk more about what we want to be building. Okay, Gabriel.
Great, thank you, Tom. Let me share my screen, or I think I start sharing. You're seeing my screen?
Yeah, I can see. I'm gonna try and turn me off as well.
Okay. Okay, so I'm going to talk about agro patterns. We're helping flower growers. And as I mentioned earlier in our first episode, it's a big industry. $30 billion in the US alone, and Colombia produces 70% of the flowers that are sold in this country. What we're doing with agro patterns is addresses this triangle. The product in and of itself are flowers, but they start off as plants that grow until they're harvested. There's also insects and disease that have their source of food are these plants. And there's also chemicals that are the ways in which the flower grower attacks the insects and the disease. What we're trying to do with agro patterns is really detect the insects and disease present in these flower beds as quickly as possible. That just basically helps the plants be healthier or just be less prone to issues. And the early detection also leads to less toxicity because insects, when they're young, are much less aggressive than as adults. So you have to use much less chemicals in order to get rid of them. And within this triangle, there's a constant, which is temperature and humidity, that affect all three pieces, all three vertices of this. Temperature and humidity are the key components for plant growth. They also have a huge impact on the growth and presence and severity of insects and disease. And they also have a direct impact on the active ingredients that are part of the chemicals that are used, whether it's fertilizers to help with growth or insecticides or pesticides. This is basically the product. We have a large farm here. The colors show the different crops and varieties. These crops and varieties are targeting specific, peak dates, Valentine's, for instance. So all the red ones are probably freedom roses, and they're targeted for Valentine's, and so on and so forth. Now, keep in mind that different varieties are more or less attractive to insects. So that's an important component that we need to keep track of. How do we keep track of insects and disease? There are scouts in the field that review every single square in a farm, and by a square we have a flower bed is about 8 to 10 squares, and the scout goes square by square, identifying and using a kind of a categorical slider from 0 to 3 to identify the severity of an issue. And in this case, it's ácaros is the Spanish word for mites. That square then gets recorded into basically like a spreadsheet where the data is shown graphically. And that's one greenhouse with about 2,000 squares. And then you see the whole farm. The scout is concerned with maybe one greenhouse, but they're looking at data in a lot of detail. Maybe the production manager is looking at the 2 or 3 greenhouses, and then the owner or the person in charge of applying chemicals is looking at the entire farm. So there's 3 different views.
I can imagine observable people here, their eyes will be popping out because you've got spatial data overlaid with temporal data and hand-collected data. It's just a fun thing to develop visualizations for, I'm sure.
Right. Exactly. Now, an ever-present variable here is the temperature and humidity. You look at when plants grow, and you realize that plants basically become dormant in this red area. So by 11 o'clock every morning with this, and this is actually a real data from one of our sensors, basically plants grow from 6 o'clock in the morning or 7 o'clock in the morning when you start getting sunlight all the way to 11 o'clock in the morning, but then they become dormant all the way up down to, maybe 5:30, 6 o'clock in the afternoon. So you're losing all this time, and there's an index called growing degree days, and you have to have a certain amount of growing degree days in order for maturity of the plant before you harvest. And so basically, if your greenhouse is too hot, the plants are not growing at all.
Yeah.
And what we're trying to do is maximize the growing degree days, so you time the time to harvest according to when you want to
So
sow these
literally,
flowers.
if the greenhouse is too hot, and this happens a lot, then the plant is not really growing, and it's just taking up space and taking up manual labor, but not really producing value.
That's correct. So I mean, if you have a contract to produce a certain amount of volume of flowers for for Whole Foods or Costco or whoever it may be, and you have and you just don't have enough flowers to send across the Atlantic, then you're in trouble, right?
Yeah.
And what people do, because they can't predict this accurately, then they overplant. So that just leads in some cases to overproduction and then waste. And this is an industry, as I mentioned before, where about 45% of all the product is wasted.
Wow.
Which is, yeah. So that's basically the use case. And what we're trying to do, and I'm just going back to the first screen. I hope you can see it because I'm not seeing myself here. The first screen is really, we're trying to detect insects and disease as early as possible. We're trying to manage the temperature and the humidity in the greenhouse as much as possible. And how it's done is basically you open curtains to ventilate it, and you open vents, and use these big industrial fans in order to just bring the temperature down, which leads to other issues like you dehydrate the plants, so you have to rehydrate them in a different way. So it's a system that has to be constantly monitored.
Yeah.
And with that, Tom, I will yield to you, and I will start talking about the use case.
Yeah, so what we're going to look at today is this temperature. Oh, wait a minute, I need to switch screen. Yeah, there we go. Okay, so what we're going to look at today, so just to review, last week we actually got data, a storage place for these fake sensors we created, mocking what we imagine real sensors would look like. But this week we can actually, I think, move on to actually integrating with real sensors. And so what we want to achieve this week is bring these real sensors, the data that they're emitting, into the system. So I believe you are using Blues Wireless sensors, which these are very interesting things because they work over the cellular system. That means, they've got SIM cards in them, and they don't need Wi-Fi connectivity. You don't need to bring the internet to them. They've got it all inbuilt. So you just buy these sensors and they work pretty much out the box, I believe. And so these sensors, I'll let Gabriel talk over this a bit more because I'm not super experienced, but they have this centralized dashboard for integrating these sensors, and I believe these are real sensors in the field.
That's correct.
Yeah, what we're going to do is we're going to add, it supports, if I go back to Blue Wireless, create a connected world. Your sensors have some boards that eventually upload to their cloud run by Blues Wireless, which can then route the sensor data to your own cloud. They suggest Azure, AWS, or custom, right? So custom, this is what we're going to do. You can pipe that data into another system. We're going to use WEBCode, which means we can sort of capture it directly in observable without any additional infrastructure. That cloud systems are quite complicated to set up and take a long time, authorization and stuff. I'm going to show you that we can do it incredibly quickly, a custom integration, without even installing any software on on my computer. So that's what we're going for, this custom integration. So the first thing is to create a route. So we're going to create a, what do they call it? A general HTTP route handler. So we need to send it to a specific URL. So this is where we need a server. So with WEBCode, I'm going to first import WEBCode SDK, which has a function called endpoint from endpoint services / WEBCode. If you've not used observable, all these things are clickable, which is really cool. So we can find the definition of that library. That library is hosted also on observable, and we can just hyperlink straight to it. So we're going to import WEBCode endpoint, which allows us to declaratively declare an endpoint, or what you might call a server. So what we're going to call this, the Blues Ingestion endpoint, and its API is, if anyone's used JavaScript Express handlers, it's modeled very much after that. So that a request comes in and you need to write your response in that. They always abbreviate it as res. Maybe we should expand that. Let's call that request and response. And this returns the administration API for this. So I'm already logged in, and this has created a endpoint. So this is literally a thing on the internet. So so we can debug it quickly. I'm going to say response.send hi everybody. If I open that link, it immediately works, and you'll notice this is webcode.run. So I'm programming on observable, but it's a webcode.run domain. This is a real endpoint on the internet. So if I do the manual curl approach, hi everybody, this returns hi everybody too. So this is live on the internet right this second. And this is extremely handy because we can also start debugging as well. So if I set a debug endpoint and now open it, open that link, it's now paused, and I've actually grabbed that at that debug point, and I can let it play and it will play. So we can actually interact with this live web traffic. And what we want to do with this ingestion point, this has created a server at that web address, which anyone can route traffic to. In our case, we want to set up this custom integration with Blues Wireless. So we were setting up a URL. This is going to be our URL. So we're going to tell it to send our data to that. Let's also be secure and set up authorization. So authorization, header value, bearer, and we'll give it a secret token. So let's generate a password. This is how a strong random password generator. Oh, I don't like it when it does weird symbols. There we are. And so that will be passed along with the request. Let's rate limit it. I always think it's safe to rate limit things. 15 seconds. I think that's fine. No transformations. And that's all we need to do. So create a new route. Oh, name your route observable. So create that new route. Right, so that's created for our observable demo. And now, if any data comes in, it will be forwarded to this endpoint. Now, the important thing is I've got this live coding ticked. And what this means is when traffic hits the production endpoint, it will tunnel it to this server, to my browser session here, which allows me to interact with it in real time. This is what enables this. So if I start logging these requests as they come in, oops, we will see it happen. I've just reset the state there. And the fact that we're getting production traffic into our notebook, this unlocks a new way of developing, where instead of me having to look at the vendor implementation and say, right, what do these requests look like? What kind of payloads do they have? I can now, instead of doing it by documentation, I can just look at what happens in reality, and using the magic of observables partial code reloads, I can not even decide how I'm going to implement this yet. So our aim is to get that data and put it into our storage system that we set up last time. But I don't exactly know how to do that. So what I first want to do is start capturing this traffic and freezing it in the notebook so that I can figure out how to program it. Like I'm not going to program it in advance. I think a lot of time is wasted on developing by, writing a program and then switching to testing the program and switching to writing. We're gonna all interleave this in a nice way. And in order to do this, I need to set up a queue from Tom Larkworthy flowQueue. What this flowQueue allows us to do is observable notebooks are written in this notebook style where there's lots of cells, and the cells are great because even though this was evaluated a while ago, we can inspect at our leisure. It leaves a trace of execution, and the state of these cells are remembered, and the fact that it remembers is what makes it very powerful for development, because we can remember what the request came in and then write the implementation afterwards. And this is, I'll close that down a bit. This is the power of the observable live coding combination. Oh look, some traffic just came in there. Hopefully we can see it printed out, yes. It printed out something, blue wireless, and the body, it had an event in it. Yeah, so this is, we're receiving data now. That was an event just came in, although it's not in a form that's easy to read yet. I'm going to approve that now. So we're going to set up this flowQueue. flowQueue. View of event equals a new flowQueue, because I know we're going to run out of timeout milliseconds. Default is 1 second. We're going to send it to 10 seconds. So this sets up the queue, and then when data comes in, we're going to send it. So I'll show you the API for this flowQueue. Has send, reject, respond. Sending means we're setting up a new one. So I'm going to send it a payload which contains the request and the response. And sometimes it's useful to include the context too, so I'm going to do that as well. And if it, this is an asynchronous thing, so we're going to wait for the data to go through the queue, and then afterwards we will send OK. So that says we process it fine. If there's an error, we will set the status to 400 to say, 500 to say there was a server error, and we will send the error.message, so we've got a clue as to what went wrong. And that's, I think people who are used to writing servers would generally expect a lot of function calls and stuff, and that's the traditional way of developing servers. But we want to exploit the affordances we have in the notebook, and instead of doing this sort of callback or asynchronous style of functional programming, we're just going to immediately throw it into this flowQueue, which will allow us to lay it out. So at the moment we're waiting for the event to come in. When the event has come in, we will respond to the queue. What is it? View of event dot respond. That we've saved it. Okay, and now we just got to wait for another event to come in before this is all set up now. So there's a queue here, and its value will be printed there. And after its value has evaluated, we'll respond to the queue, and that means like that job is finished. That's the point that promise evaluates. So there's nothing been tunneled for a while yet. So we've got to wait until these sensors emit data. Could take up to 5 minutes. In the meantime, I think we should switch over to Gabriel. Okay, are you ready for me?
Yeah, I mean, I think what's important, the sensors are reporting data every 15 minutes, which is enough. So basically, now, one thing that I want to stress about this technology and our use case is that not everybody is in front of a computer all day long working like we seem to be doing always. There's a lot of people that work, whether it's in a factory assembling cars, or in our case, in a farm that it doesn't have a connection to the internet, and they're cutting flowers or tending to the flowers or counting or identifying the presence and severity of insects and so on and so forth. And there's a multitude of these use cases. And for these use cases, people do rely on technology, but they rely on technology differently than we do. They want information that is it's at their hands, and it's very concrete. For instance, one example is I want to know the current temperature of my greenhouse. So I should be able to type from my WhatsApp phone, hey, give me the temperature of the greenhouse now, or the last temperature, which would have been within the last 15 minutes. And this bot of sorts, or this application, should be able to throw a graph of the current temperature, and maybe show a range of what's acceptable, or if it's out of range. Or I can ask, if I'm trying to define the plan of chemical applications for the next day or two, and I'm right there in a greenhouse. Well, the greenhouse, as I mentioned earlier, or in the previous episode, the greenhouse is the size of a football field. So if you're on one end, you probably don't know what's happening at the other end. So I want to see the graph that I showed you earlier of all the presence and severity of mites in the entire greenhouse. So I can, just by typing, hey, give me mites in the greenhouse, I should be able to get a graphic back to my cell phone. And when I mentioned cell phones, I know that I mentioned in the past that farms don't really have Wi-Fi, but the cellular network is very pervasive in the rest of the world. I mean, or everywhere now. So, and SMS messaging, it just has a lot less volume than a full-fledged app, right? Whether it's video or whatnot. So just sending an image over the cellular network is very feasible, and that's exactly what our users need. They don't need a sophisticated dashboard with a bunch of different beautiful graphs. What they need to know is just what's going on in the field right now.
And how are you imagining getting data to users' phones?
Well, I mean, ideally, what I'd like to see is I'd like to see an observable graph, whichever it may be. It could be like the ones that I shared with you earlier, but then being able to send it via SMS or some SMS client. It could be WhatsApp, or it could be some type of a device that can be sent to the user quickly. And in fact, in response to some request that they make, I could be asking, what is the tendency of mites over the last 3 weeks? And I could get a little graph of either a line moving upward or downward. then I can ask, or I could be asking, how much have I invested in mite prevention in this greenhouse over the last 3 weeks? And I just get a very concrete bit of information instead of, a bunch of stuff.
Yeah, I've noticed a lot of businesses during pandemic started using WhatsApp a lot and have bots and things. There's a lot of bots for it. And yeah, you're right. Like, what's special about WhatsApp is it will operate just using cellular connectivity. So yeah, you don't need a Wi-Fi connection or a general data connection. Just any kind of a feature phone connection is enough. So yeah, that's amazing actually, to use WhatsApp to provide information to workers in the field on demand. And that is definitely something I think we could prototype, and we will probably do that. Fingers crossed, if this goes well, we can try and do that next week. There's a few gotchas with WhatsApp, is that they have quite a lengthy sign-up process, but I believe Twilio has a sandbox which we can use without much overhead. So maybe next week we'll try and get Twilio sending and receiving data, and in some ways it'll be similar to this, because most of these systems just generally end up turning into a webhook implementation, and WEBCode is very strong for these webhooks, and yeah, so it won't be that dissimilar. Only, like you say, we want to read the data and maybe send a graph back. That would be quite cool. We'll see how much possible this is. So, we had loads of data when we originally set this thing up. Now we're waiting. So I know with this notebook we can see what events were recently sent. So we can debug. Maybe we've made a mistake and we've lost some data. So last uploaded was 22 minutes. So that was 10 minutes ago. If I refresh it, is this the freshest data? Oh yeah, we're just waiting. It hasn't even tried to send data yet. Okay, the wait continues. Let's wait for some data. Yeah, so when it sends data, so last time we did have a data point at 22 minutes past. You can inspect these routes and see the route log. So it did send to the observable demo, but that's before we'd implemented it properly, and our endpoint was just saying, hi everybody, where the state is 200 code. So it's great. This Blues Note Hub will give us information. So, and that's very handy, because if we have an error, we're going to send the status 500 and say something went wrong. It's sometimes hard to get access to these logs, but it's already logged by Note Hub. So that's exactly why I always make sure you print out the error message. Oh, tunneled 1, something just happened then. So tunneled 2, something else just happened. So if we look at the events, so I think one just came in. Yeah, 33 minutes past now. Yes, we had 2 payloads come in. We can have a look at the route logs as soon as we're here now. The route log, observable demo now said text OK. So now it got to that path. And here's where it gets interesting, because we sent that request, the whole request object, into this flowQueue. And that means the first, the value of event is filled in by the last one that fired. So that's this one. You see, this was a gray bar. Now we can actually open this and expand and see what happens. So the request body included headers, authorization bearer gibberish. That was that agrees with our observable demo here, bearer gibberish. So that's interesting. It's also got this body payload which looks like JSON. So I expect we can. So this is what I mean. I don't need to know what it looked like in order to program it now, because I've captured it and now I've got autocomplete as well. So request.body, I can see that that's JSON. so I can pass that. And there we go. This is, I believe, the sensor information. Yeah, look, there's a humidity, there's temperature. So that's come from, where was it? Bogota. There's the data. That's cool. That's very cool. I want to, at the moment, this is an open endpoint, which means anyone can just start spamming us with rubbish. What you need to do is secure this endpoint. So I'm just going to do a quick boring bit where we secure that. And what we're going to do is use that authorization header. So what we need is a secret. I think this is the best way of doing it. I'll create a new secret. And the secret will be, oh, I already had one. Yeah, okay, aggro patterns, and I'll, just for the sake of simplicity, I'll include in the bearer bit, because it's easier to do that way. So I'm going to save this secret, and now I'm going to bind that secret to the endpoint. So now the endpoint will view that in the context. So if we look at the context, event, let me do it in a new cell. Event.context contains, these are information. At the moment the secrets, this is extra information to do with how this endpoint is running, and it includes, you know, what notebook it's running in, the namespace Tom Lark, whether this is like who's the administrator for it, and any secrets bound to it. I've only just bound the secret, and that's the old endpoint, so we don't know that. But our next stage would be to check the authorization. So let's create a cell called check authorization, check auth, and this will require looking at the request headers, what was the so see, I don't need to remember these things. This is the beauty of it. I don't know how to spell it. It's called authorization. So based on real data that was collected. So if that header does not equal what we're looking for, and that we had another data point come in here. So now the secret's filled in. Oh, it's aggro patterns. Actually, it's bound to the old one. Context.secrets. So if the authorization header does not fit that, now we have a problem. So we're going to reject it. And we reject things, was it in the flowQueue? So normally when the flowQueue, you want to end it like the happy path, you respond with a value. If you want to say that it broke and you want it to throw, you reject it. And the reason is, we'll create a new error, not authorized. And actually, what I like to do is return the proper HTTP error code. So the error is a new error, and the way I usually do this is set the code to 403, and then I reject the event with that. And then, because I don't want this cell to run anymore, the chain of cells in the notebook to run anymore, I will return the invalidation promise, which is a special promise that only resolves when this thing reevaluates. So it just means this evaluates and that breaks. And there's no such thing as request, it's event.request, and there's no such thing as context, it's event.context. Okay, so this is correct now. I'm just a bit worried that, when did we last get a thing? I don't think that updated. So it keeps thinking it's secret. Let's just go with what that equals. if authorization does not equals bearer, the value in there, which is secret, and we'll throw an error. So what I'm expecting to do is that when I run this, this should not, what we expect is that this block of code, which is when you fail, this should not happen. So we'll say return okay, and we're expected when I run this for this to say okay, but it's not, which means this logic is wrong. So now I need to debug why. Clearly, because of this grey bar here, means that this cell is not evaluating to a real value. It's evaluating to that invalidation. So why is this happening? Because I changed. I think this all matches correctly. So there's obviously some kind of problem in here. So the way I debug these is we use JavaScript's inbuilt debugger expression. Now I run it, and now we're here, and I can step through and see what happened, why it didn't behave in the way I thought it would. And as you can see, yes, it jumped in there. So what does it think the value of these things are? I think, yeah. Oh no, look, like the headers is now that D9. Oh yeah. Yeah, so yeah, the incoming, yeah, it matches this thing, but we want to change this because for some reason the secret hasn't updated. So has that updated? Yeah. Okay, so this should resolve in a minute. Yeah, because the incoming payload's wrong. And this secret is currently secret, and the incoming request is using the other one. So this is now paused because it's not passing security. I want to actually program this, so let's just for now completely bypass this, and because we need more data to come in before it all starts working. So live coding, we're back at 0, and we need to wait for more data to come in. But we've still got this data, so we can do the implementation now. So what we want after this one evaluates, check auth comes to that. The next thing is to upload to Firebase is the next step we want to do. And I reference the previous cell that I want it to depend on. So this will only evaluate after this one's evaluated. And so either this will fail and reject it, or the chain of processing will continue from here. And now we've got upload sensor data. This is how we were doing it last time. So we'll just copy all this now. This is what we did last week. Hopefully that will still work. Upload to Firebase. And the sensor name, right now we need to fill out all this based on real data. So upload to Firebase. Let's just have a quick look at the let's decode this. Is JSON.parse the event request.body. Okay, so this is our data, is the sensor, and maybe device is the thing we want to. It's the thing we want to record it under, I think. Is that right, Gabriel? What would you call the sensor name?
Yeah, the device is fine.
Yeah, okay. So what we called it sensor. Now we can call it device, and probably it's got its own notion of time. Before we were generating a local time, but that's probably a bad idea because these things will sync, when they can, but they'll know when they were supposed to have synced. So I would expect there to be some kind of clock here. Is there no timestamp? That's crazy.
There is best location. Well, no, best location when.
Oh yeah, that is a timestamp. Yeah, okay, that's confusing. Yeah, that's the cellular mast time. Yeah, that's the
Yeah.
So, at that time we will record it. Let's also set it there and set it there, and the temperature comes out of the body. So we've got the sensor.body. You know, actually, rather than try and I tell you what's probably quicker than me copying everything over. It's better, you know, as things upgrade, it's just to put the whole payload in. I'm going to put everything in the Firebase, and then that means, you know, we've captured all the possible information we need. If they change the schema from out from under our feet, we're not going to have to update this piece of code. This is like simple and effective. So this would upload to Firebase, and then we want to return OK. And it has uploaded to Firebase, that's interesting. And then once it's finished up, so this is what I love about observable. You know, I needed more information. You know, I just create a cell, I then delete the cell. So we want, after that's uploaded, then we want to respond, and that's the end of the data processing. So what this path now does is when we get an incoming request from the Blues Wireless, it will write to Firebase. And then what we want to do is a streaming read of what's coming out of Firebase. So we have to choose what sensor name it is. Oh yeah, so last week we wrote these queries so we could see what was happening, but we didn't know what the format of things was. So now we just need to update what we're querying for, I guess. So we had this live stream. This is using, you know, the special thing about Firebase is it can do streaming queries. So these update in real time. And it's based on the sensor to query. Let's change its default value now to that one, our new one. Hey, and look, now we've got data coming out of it. There's only one data point so far. But that's the data we just stored there. That's a data point, and then later we tried to display that data point with a live plot. So what we're interested in is the humidity, the temperature, out of the live view data set. So what's the live view data set? We've only got one thing in it, and the interesting data is tucked away in its body temperature. So that's the temperature, and the other thing is it needs the time, which we figured out was that best tower location when. Oh no, here we go, it's just got when. Yeah, that'll do. Date.when. Will that work? Cannot read properties temperature. Yeah, that's correct. It's d/body/temperature. Okay. So this looks promising. It looks sort of on the right scale. Maybe this date is not very good. Let's have a look at this. Let's debug this date a bit more. So we've got the live view. We can look at the first data point, and we can look at when. And then what I did was just surrounded it in a date object, and that said in 1970-01. So this happens a lot if you're used to working with timestamps. Is usually what happens is they're off by a factor of 1,000, depending on whether they're recording milliseconds or seconds. So I suspect timesing it by 1,000, yeah, I guess correct, suddenly gets it to today's date. So That's the mistake that is making this x-axis a mess. So times it by 1,000. Okay, and it was, I don't know why it's saying 59 seconds ago, but I think that broadly is correct, but we've only got one data point, so the graph is not very interesting yet.
You may want to change it for a bar graph.
Yeah. Okay, yeah, there we go. And now I wonder, yeah, look, we've had some more stuff come in. I wonder why they've not. I would expect those, so we've had some more data points come in. Now the question is, why don't we have 4 data points here? Well, I'm also confused why that's there, but why have we not got these 4 data points? So let's see what's happened. And this is the beauty of having this live coding, is that I can now inspect what has happened in the past and see what came in now. Is probably this authorization is bearer secret. So our changes there happened, which probably means, and what's the context secret? Is secret as well. So probably I can now turn on authorization. It should still say okay. No, what's happened is this different sensor that's reported. So everything did fire. So is this a different sensor? This is the issue, is that we can choose which sensor to look at. What was it? So let's move this around to our dashboard. So if I change this, will this be a different reading? Yeah. So this one's at 16 degrees, and our previous one, it was a different one. Yeah, we are getting more data. It's just that, you know, they're different sensors. But that's pretty much as far as I hope we'd get, if not slightly further, because what we've done now, what happens when we turn off live coding, right?
Hey Tom, maybe you want to try out on the x-axis having the sensor instead of the time. Maybe. So you can see the multiple sensors.
Well, no, I can't, because that won't work, because the thing is that it's reading data from this live view query. This only has data from one sensor, because we're querying by sensor name. We can get the history of an individual sensor.
Fair.
Yeah, so if we want to like compare 2 sensors, we need to issue 2 queries here and then combine these data sets. So we could do that, but like, you know, I don't think we'll have a huge amount of value in that. What we want to see next week is to leave this running. This is what I'm interested in now, is what happens when we turn this off. So before, when we clicked on this, that request, you know, we'd open a new tab. This request would be handled by our local browser session. We'd see a tunneled session. Now we've turned it off. What happens when you turn off live coding is that in WEBCode servers, what we do is, if there's no tunnel, no developer with an open tunnel, we drop down to creating a Puppeteer instance server side, and that actually the server browses to this web page and opens it, and this is how it works. So what I think has happened is it says the error it's thrown is there's a timeout, maybe increased timeout milliseconds. That's the error message for this. So for some reason it got to this part and then run out of time. So I don't know why that is, but when there's no live coding tunnel open, it falls back to the last published version of this notebook. So we didn't actually publish it for quite a long time. So I published it then, and then maybe it will work now because it was just running the wrong version. Yeah, not authorized. that makes sense, right? Because we didn't supply the secret. So just to, yeah. So if I curl that endpoint now, not authorize, and then in order to authorize it, I need to set the header authorize. What was it? Authorization bearer secret. I think we decided on in the end. Oops. And I misspelled bearer wrong. Okay, so this time it's clearly past authorization, but we didn't actually put a payload in it, so this is gonna cause problems. Yeah, so then it failed, probably because it couldn't serialize it. That's just a bug. We're not really handling stuff, but there you go. So now we've turned live coding off, we should hopefully see that despite that, these events will still be going in. When was the last one? 53 minutes past. Okay, well, we don't really know yet. But I think this should be working now. And we don't need live coding on. And we can close this and it will just continue to work without us. For me, that's an achievement. And this is an easier way to code in than, you'll notice that I've never clicked deploy at any point. We've got a server running for real on a public endpoint. I've never had to deploy it. It just worked instantly. We are able to bottle the incoming events and spread them across this reactive notebook so that we can code based on information that's come from reality, and it's this live coding that enables it to us to redirect production traffic into our notebook so that we can develop incrementally without restarting. And I think this is a better way of doing things. Any thoughts, Gabriel?
Yes, I mean, from our standpoint, it's just the fact that, within an hour, you were able to hook it up all together with the Node Hub. And now, from my perspective, I'm not that good of a coder, but I can develop stuff in Observable. So I can read the data, and I can create the graphics that I need. Right? So, I don't know about what other people do, but within an hour, we set up everything in order for data to be coming in from an external service.
Yeah.
And just like we with our sensors, we can do it with, let's say, maps. So, I'm looking at a really cool technology called PlaceMark, and if you can publish the data in PlaceMark, then I can push the data over to my agro patterns. So, this just opens up a lot of opportunities for us.
Awesome, glad to hear it. So, yeah, we've just hit the hour mark now. That's pretty much a great time to finish. So, yeah, we achieved what we want. The tarot was correct. It was a success. It went as planned. Next week, as we mentioned, we'll probably try and get onto the WhatsApp integration. So far we've got incoming data. It's stored in Firebase. We can graph it. Next week we'll have a bit more data to graph. So we'll just wait for that to fill out. And then what we want to be able to do, field workers want to be able to query this via WhatsApp and get a response. So we want to be able to send graphs over the wire to WhatsApp. And the amazing thing about this is Blue Wireless sensors work over cellular, WhatsApp works over cellular. So this will all work from a feature phone. We've not installed anything. It's going to be cool.